A significant development in the global space race has emerged with the unexpected sighting of a massive aircraft carrier transiting near SpaceX's Starbase. This raises intriguing questions about potential future roles for such platforms in space operations. Could a repurposed carrier facilitate the transport, landing, or even launching of SpaceX's Starship rockets? The observation underscores the growing need for innovative solutions in space logistics. Meanwhile, NASA's Viper rover, previously at risk of cancellation due to budgetary concerns, appears to be back on track. This resurgence in lunar exploration projects highlights the renewed commitment to lunar missions, showcasing a collaborative effort between government agencies and private companies. A key element is the rising involvement of private aerospace companies like SpaceX. China's move to utilize privately developed rockets for the Tiangong space station is another significant development, emphasizing the growing global competition in space exploration and commercialization. This suggests a dynamic shift in how nations approach the vast expanse of space. The implications of these concurrent developments are multifaceted, impacting future space operations, resource utilization, and international collaboration. The implications of these developments extend beyond individual missions, suggesting a possible future of international cooperation and competition in the realm of space exploration. The recent transit of the USS John F. Kennedy, a retired aircraft carrier near SpaceX's Starbase, has sparked considerable speculation regarding its potential repurposing for Starship operations. Its immense size and capacity could potentially revolutionize SpaceX's logistics. The carrier's substantial payload capacity, ranging from 22,000 to 82,000 tons, presents a unique opportunity for transporting significant amounts of equipment and potentially even entire Starship units. This raises the possibility of utilizing the carrier as a mobile launch or landing platform, significantly altering the logistics of future missions. Two primary landing scenarios are possible: a drone ship approach, leveraging Starship's existing landing legs, or a more complex catching tower system, similar to SpaceX's existing Mechazilla system at Starbase. The scale of the carrier, measuring 321 meters in length, could accommodate multiple Starship landings or even launches simultaneously, highlighting a potentially game-changing development in space logistics. The practicality and efficiency of a sea-based platform warrant careful consideration for future Starship operations. This suggests a shift from traditional launch sites to more versatile, mobile platforms, with considerable implications for future space missions. The potential use of a repurposed aircraft carrier for Starship operations presents several innovative logistical possibilities. A sea-based platform could significantly enhance the efficiency and flexibility of Starship recovery and transport. The carrier's vast size could accommodate multiple Starship landings simultaneously, dramatically reducing turnaround times and optimizing fuel usage. This drone ship method, where Starship lands on the carrier's deck, avoids the challenges of pinpoint accuracy at fixed land-based launch sites like Starbase. This could significantly increase the versatility of Starship operations, as the carrier could be moved to different locations, enhancing operational flexibility. Moreover, such a carrier platform could potentially facilitate more efficient fuel usage for Starship return trips. It would eliminate the need for Starship to expend additional propellant for a return-to-launch site maneuvers, maximizing the overall flight performance. The logistical advantages are substantial, and the potential for drastically reduced turnaround times is a major factor in achieving greater efficiency in space operations. The enormous scale of such a carrier could also potentially support multiple recovery attempts concurrently. This could significantly improve efficiency and potentially reduce the overall cost of future missions. This innovative approach to space operations deserves serious consideration, as it could lead to substantial savings in resources and time. NASA's renewed focus on the Viper rover mission signals a crucial step forward in lunar exploration. The project, which had faced potential cancellation due to cost concerns, is now being revived through a collaborative approach with private companies. This public-private partnership presents a significant opportunity for both NASA and the private sector. The initiative aims to leverage commercial expertise in lunar landing and surface operations, potentially accelerating the mission's timeline and reducing costs. This collaborative effort seeks to capitalize on the innovative capabilities of private companies like SpaceX, which already possess extensive experience in spaceflight. The partnership allows NASA to address the crucial aspects of the Viper rover mission, ensuring its successful implementation and scientific objectives are met. The ability to collaborate with the private sector is invaluable in the realm of space exploration, given the sheer scale and complexity of these endeavors. This revived initiative could unlock new avenues for scientific discovery and technological advancement. The selected partner will oversee critical aspects of the mission, including the rover's integration and successful landing. The announcement of the partnership proposal represents a critical milestone, signaling a new era of collaboration in space exploration. This collaboration will streamline the mission's execution and potentially accelerate progress on other ambitious lunar projects. China's recent announcement regarding the use of privately developed rockets for resupplying the Tiangong space station signals a significant shift in its space program. This move mirrors a similar trend in the U.S. aerospace industry following the retirement of the Space Shuttle, where private companies like SpaceX stepped in to fill the void. However, a key difference emerges. China's approach appears to be largely focused on replicating existing systems rather than driving technological innovation. The rockets, the Huang and Qingju, reportedly based on, or at least inspired by, SpaceX technology, indicate a strategic choice to leverage existing designs rather than pursuing novel solutions. This raises questions about the long-term technological advancement within China's space program. This strategy of using existing technologies could be more cost-effective in the short term, but it may limit long-term innovation and technological advancement. The utilization of privately developed rockets for resupply missions to the Tiangong station underscores the growing importance of the commercial space sector in China's ambition for expanding its presence in space. This approach could also be seen as a way to reduce reliance on state-owned enterprises and to foster competition within the Chinese space industry. The implications of this move extend beyond the immediate context of space station resupply to potentially signify a broader shift in China's approach to technological development and international competition in space. The potential repurposing of a large platform, like a repurposed aircraft carrier, for Starship operations introduces significant advantages in terms of logistics and flexibility. Such a platform could serve as a mobile launch and landing site, offering significant advantages over traditional land-based facilities like Starbase. This mobility would reduce reliance on fixed locations and mitigate potential disruptions. A sea-based platform's capacity to accommodate multiple Starship launches and landings concurrently would significantly increase operational efficiency and potentially lower costs associated with recovery operations. This could also contribute to reduced turnaround times between missions, making space exploration more rapid and effective. The logistical benefits extend beyond landing operations, potentially enabling more dynamic launch sites. This flexibility could also extend to transporting significant amounts of equipment and supplies between different locations. Repurposing a platform like a carrier could revolutionize the logistics of spaceflight and reduce the logistical burden associated with maintaining a fixed infrastructure on Earth. This innovative approach could reshape the economic and logistical realities of conducting future space missions by lowering costs and increasing flexibility. However, implementing such a system would require significant engineering adaptations. SpaceX will attempt to catch Starship rocket at next launch. SpaceX will attempt to catch the biggest rocket ever built in a world-first maneuver next month, Elon Musk has revealed. The fifth major Starship flight test will be the most ambitious yet for the 120-meter-tall rocket system, with SpaceX planning to deliver it to orbit before recovering the Super Heavy booster in order to use it for future missions. Unlike its Falcon 9 rocket, which lands autonomously on a launch pad, SpaceX plans to catch the Super Heavy rocket using robotic arms built into the launch tower. The so-called Mechazilla tower will be in operation for the next Starship flight test, which Mr. Musk says could take place within the next 6 weeks. In response to an animation of the maneuver posted to X over the weekend, the SpaceX boss said he was aiming to try this in late July. SpaceX began construction of the next-generation launch tower at its Starbase facility in Texas in 2021. Measuring 146 meters, 480 feet, it is the tallest launch tower in the world and could provide the basis of future planned Starship launch setups in Florida. It is designed to support launch, vehicle integration, and catch of the Super Heavy rocket booster, SpaceX explains on its website. Catching the booster reduces mass from the launch vehicle, moves hardware complexity to the ground, and enables rapid reuse of the rocket. Following liftoff, and after the two stages separate in flight, Super Heavy will return to the launch site, reignite its engines to slow the vehicle down, and the tower's arms will catch the rocket booster before restacking it on the orbital launch mount for its next flight. The previous Starship flight test on 6th of June saw SpaceX perform a splash landing of the Super Heavy booster, successfully returning it to Earth in a major step towards achieving reusability. SpaceX ultimately aims to build a massive fleet of Starship rockets capable of transporting crew and cargo throughout the solar system. According to Mr. Musk, the rocket will allow a human colony to be established on Mars within the next 10 to 20 years.